So what is file I/O? It's writing things out to a more permanent structure than just memory, right? Your memory is lost when you turn the computer off. You like to save it to a disk or to flash RAM or, something like that. So in C, they're done with file pointers. That's a low-level operating system, and C is just a wrapper for the file handles, so that commands to print or something like that get translated directly into calls to the operating system to go and write a series of bytes to the file that's currently open. We've already used some file pointers. We've used standard out and standard in if we've been using fprintf and fgets to do output and input from the console. That's all that that's all that printf does, is send something to standard out. And that's all that scanf does. Reads from stdin. So to declare a file, we just use file star as our data type. Like that. They're also known as streams, so you'll hear those terms used interchangeably. File pointer and file stream. What does stream imply? It's a series of characters, a series of data. So you open a file with fopen. You pass it a file name, and you pass it a mode. And there's a whole bunch of different modes. So for example, we declare our file pointer. We call it like that. We give it a mode, R for reading. We give it a file name. If it successfully opens, we get a valid file handle. If not, we get null. So after we call fopen, we need to check to make sure that we didn't get null. If the return value is null, then the file was not open. Might prompt the user again, or whatever we need to do. So there are lots of different modes. You can open files in text mode or in binary mode. Text mode is when you're just printing things. It's all text, just like we were reading from standard in and writing out to standard out with printf. Same kind of stuff, except you're putting it in a file or reading from a file. So the text modes include read, write, append. What's the difference between writing and appending? Writing wipes the file out, it truncates it down to 0 bytes. Appending opens the file and sets the current pointer at the end of the file, so that when you print to it, it adds to it rather than overwriting it. Then there's read write, and then there's W+, which read writes, but it truncates the file first when it's open, which is different than reading. Reading assumes you're going to be reading from the file, so it doesn't erase it. Write plus assumes that you're going to be writing to the file before you start reading it, so it wipes it out. And then A+ moves the file pointer to the end, so that if you write, it'll write it at the end. And there's binary modes of all of these. If you're going to read binary data is what you would use if you're going to write an array out. Just pure numbers, just pure bytes. Or if you're going to write a structure out. So if you're going to use blocks of memory, then you would open it in binary file format. So same things. Read binary, write binary, append binary, and so on. Just tack a B onto the mode and you're good to go. Do I have 2 duplicate slides? Why, indeed I do. So fopen returns a file pointer, otherwise it returns null. And errno will be set to indicate the error. The errno is a global variable in C programs. Let's play with that. I'm going to open sigwin. Touch July30.c. I'm going to go and open that. Where is he? July30.c. All right. GCC it just to test out our compiler, make sure everything's working okay. Okay, file .h is not necessary. Delete that, save it, rerun it. Yeah, okay. I'm going to create a pointer of the file type, file star fp. I'm going to open a file that doesn't exist. fp is equal to fopen. I'm going to pass in a file name, sample.txt. I hope there's no file with that file name in there. And then if fp is equal to null, we have a problem. So I'm just going to print f, error opening file, semicolon, errno, E-R-R-N-E-O equals %d, \n, end quote, comma, E-R-R-N-O. Just to find out what errno gets set to. We could Google up errno and find out all of its different possible values. Else we could do some stuff with that file, right? We have a valid file pointer at that point. And at the very end of it, we might close it like that. We'd want to put that either inside the else branch or outside it. If we do outside, we want to do if fp not equal to null, fclose fp. Because we want to check it before we try to close it. Just like you don't run it, execute free on a pointer that has been set to null. All right, if that file doesn't exist, which I hope it doesn't, then we should get that error message. Error undeclared. Did you mean P error? I don't know. I just read about error and got all excited about it. All right, how about P error? Yep, just like they said. So instead of error no, I'm going to print P-E-R-R-O-R question mark in question. And if that doesn't work, I'm just going to stop caring. Yeah, forget it. Really? I wanted to see it work. Okay, I have to do extern int errno. Is that so? Maybe that would have done the trick. I forgot that. So I'm going to add extern int errno, and I'm going to change this back to ERRNO. And now if it doesn't work, I really am going to quit it. Alrighty. All right. Forget it. Delete extern int errno.
Save the file. No, you didn't put include errno.
Do we need to include errno?
Yeah, include errno.
And I keep accidentally launching the Java browser. Aha! Is that easy? Okay. All right. Error opening file, errno equals 2. If we Google up errno codes, no such file or directory, 126 more rows. There could be a lot of errors then. Where are they? There they go. Oh boy. Yeah. Anyways, so you open a file. If it returns null, you're in trouble. If it's not null, you can start reading from it. Well, I'm just going to put a line of text in there, and then I'm going to call fgets to get something out of it. To get something out of it, I need a string. So char sz data 80. 80 is just a purely random number, of course. Then when I call, I'm going to do int x equals fgets, parentheses, the pointer, which is fp, followed by the data, and I have this in the wrong order. I believe the file pointer is the last thing that gets passed in. Yeah. So move that fp to the last thing in fgets. Morning. Initialization makes integer from a pointer without a. Okay. Tell you what, I'm just going to hit the slide on that. All right, so once you get the file open, if you've opened it for writing or appending, you can call fputs. Fputs just sends something to the file. It just sends a string. It doesn't put a /n at the end of it, but then again, neither did printf. So if you want to put a /n at the end of the string, you make another call to it, or you embed it in the string that you're trying to print. So just like this, if we open a file for writing, we can append some stuff to it. It'd be worth doing that as well. I just want to get this last the example we had working, and then we'll skip back to that. Okay, so fprintf sends formatted data to a string, just like printf did. All the same %ds, s's, and stuff like that. So our example, we open the file for writing, and then we fprint some stuff that says we are in 2008, and we close our file. And if we were good programmers, we would have checked to make sure it wasn't null before we went crazy writing to it. So fgetC gets a single character. FEOF tests to see if we have hit the end of the file. When we're reading, you need to know when you've hit the end of the file. It returns a non-zero value when end of file has been hit. Otherwise, it returns 0, so you can just execute it like this. If FEOF, pass it our file handle. And since we're usually reading inside of a loop, you could put a break there, or you could handle the logic however you like. So fgets reads a string of that length from that file pointer. It stops either when n-1 characters are read, or the new line character is read, or the end of file is reached. n-1, because if your string is declared out to 80 characters, your buffer is declared out to 80 characters, it needs one last value at the end in order to hold the null. So you would have bytes 0 through 78 containing valid data, 79 would be null. If that is the case, there will be no new line character involved. But if the amount of data, if you hit the end of the line, there will be an ASCII 10 in there. There will be a new line. That's the way that you can differentiate whether there was still data waiting in the buffer for that line or not. The user typed in more data than you wanted to read. Sometimes you need to clear that data out. So on success, it returns the same string parameter. Seems kind of silly, right? We passed in a string, we're going to return it. But if an error occurs, the null is returned. So if you're calling fgets, you could check its return value to see if an error occurred. So here's an example of it. If fgets, we pass in our string, we pass in our length, and we pass in our file pointer. And if that was not equal to null, then yay, we got some data. We're going to do something with it. All right, why did that not work here? What did I have wrong in my code? Because it needs to be a character pointer. That's what we're passing in, that's what we're getting back. I'm going to change that to ret for ret val or something like that, just so we can check the error code. For now, I'm just going to print the error code. Printf, f gets returned. %d, \n. What's a string? Yeah, I'm going to print it out as a pointer, I guess. And then print out retval. And there I go again. All right. Well, now I need my file to exist. I'm going to open the same file that I'm working on, July30.c in my case. But eventually I'm going to create a text file. July30.c. That's my file name. Don't open your C file for writing. But for reading, it's okay. We're just reading ourselves. All right, and it returned a non-zero value. That's the memory address of our string. So we could do something useful with that. You know, if retval not equals null, we could print out the string we just read. Printf read : %s. We don't even need to. I'm going to put single quotes around it, like that, just so that we can watch the new line character get printed out, which we would want to strip out. Okay, so read %s, comma, and then our string is called SCData. We could also print retval there. They both point to the same memory address at this point. All right, and we read the top line of our file. Usually what you want to do is you want to loop till you are done. So why don't we just put this in some kind of loop. While true, something like that. So I'm sticking while true inside my else. I'm going to tab everything over. And I'm going to close my, all right, I'm going to put some comments here to make this easier to follow. End while, and this is end else. Now this isn't going to do what we want it to do, because it's not going to stop. So we've got it, there's no break statement, there's nothing that'll prevent us from, so let's just give it a shot. July30.c, while true. Oh yeah, we're not dealing with a language that has the true keyword. Just make that while 1. Maybe we can come up with a better, more elegant way, but this is pretty common. Try that again. Okay, that worked. /a to run it. Alrighty. Obviously, we need a break statement there. So here is where we need to check to see if it's null or not. We don't really need that print statement anymore. So I'm going to do this. If retval equals null, break. And if we do it that way, we don't need to have this if statement here. You know, or we could change it to else, something like that. It's not strictly necessary if we're going to break out. I'm just going to make it say else. But you see what I mean? If you're breaking, great, and if you're not breaking, then automatically everything else after that is an else. So I could get rid of the else keyword entirely, and the opening brace, and the closing brace, like that. And if you'd like putting the break on the next line, as we actually should, there we go. So this should open our .c file, read the whole thing in. Reval is undeclared. Oh yeah, reval. Thanks. Okay. Let's do that. ./a, run it, and it printed out our CPP file.
So you think that's how cat works?
Pretty much. Yeah, that's what cat does. So right, if you do cat July30.c, it just dumps it to standard out. If you want something that's a little bit better, there's the programs more and less. So you could do more July30.c, and you can scroll up and down, or at least hit the space bar to get to the end. I think less lets you scroll up and down.
Less doesn't work.
Yeah. And is less a silly name for a program? Yeah, but it was developed after more. I do. Yeah, all right. Okay.
The only thing I learned from my Linux class is less doesn't work.
Yeah, yeah.
The only thing.
Less is even better than more.
Exactly.
Okay. So, we've written a program that'll open a file and spit it out. Let's create our own file. Tell you what, I'm going to go back to the PowerPoint. Are we all good, or do I need to come eyeball your screens? Okay. So then you want to call fclose on it, but you don't want to pass in null. I can't guarantee that maybe they made fclose smart. What happens if you fclose null? That would have been an easy change for them to make. Compile it. Run it. Yeah, okay, they made it nice. You better not call free on a null pointer. Oh, I think that's the case. But you can call fclose on a null pointer and it doesn't choke. So obviously in their code they just did something like if fp not equal null, and then do some magic. Get rid of that. All right, so all the other examples coming up use this structure that I made called DataPoint. So I'm just going to step through these, and then we can think about whether we want to write them or whether we want to come up with another example or something like that. So we have a structure called DataPoint. It's got a sequence number and it's got a data value. X is the data value. And the sequence number is just something that's going to increase. 1, 2, 3, 4, 5, 6, 7 each time we create a new structure. And we're going to try to automate that. How are we going to automate that? By use of a static variable. I don't recall if we've talked about static variables. A static variable is a global variable, but it's only accessible within one function. You could just use a global variable as well as a static variable, but the advantage of a static variable is that it's self-contained inside that function. Nothing else can accidentally change it. So for an example of that, I'm going to come up and create just a silly test function, void test, and I'm going to create a static variable, static int x is equal to 0, but every time we call it, I'm going to increase x by 1. Printf x equals %d\n. And then I'm going to call test a few times up here in main. Test, test, test. GCC July30.c /a. All right. X equals 15, x is equal to 0, x is equal to 0. Is that what I expected at all? Nope. Oh, what is wrong? I made a really dumb mistake here.
Your char is X.
It's with my printf statement. I just didn't print the variable.
Put it there too.
Yeah, why don't I put a parameter here?
Is your char X or did you change that?
Where would my char be? I'm sorry. I'm not seeing it
I
yet.
changed it to ref val. I can't remember.
Oh, okay, down here. That would have been. You're right. You're right. We did have to change that. Char star ret val. And if we had wanted to, we could have made our while loop based on that. I could have declared this outside of it. I'm going to undo all these changes. I'm just kind of mulling. And then we could have done that. And then maybe we wouldn't necessarily have broken there. We just would have checked to make sure that ret val was not equal to null, like that, you know. And if it was not equal to null, then we could print it out. That's alternate logic. Break statements. I kind of like break statements. The logic makes sense to me. Okay, I'm going to undo all that. All right, so printf x equals comma x. All right, and so we see that it printed out 1, 2, 3. If this wasn't declared a static, it would just print out 1, 1, 1, because this would be reinitialized to 0 every time. A static variable is one that only gets initialized the first time that function is called. So the first time test is called, x is created. If it was not declared a static, it would be reinitialized every single time. But by putting the static keyword there, I mean, I guess I better prove it. But you know that's true. Yeah, so it's going to print out 0, wait, excuse me, 1, 1, 1, because it was reinitialized every time. But if we had a static keyword there, then it is not initialized every time. It is initialized only once. And so it is, in effect, a global variable that is accessible only inside that function. Which doesn't make it very global, does it? But its memory is allocated outside of that function, just like a global variable's memory is allocated. What I'm going to use that for is for a counter. Every time I create a new structure, I want to increment a sequence counter. So let's make our little test structure. Struct data underscore point, is that what I call this? Let's go check. That's not checking it. Yeah, data point without the underscore. And I'm going to have a string in it as well. And in all my examples, I did something snarky that I don't think that I actually just diagrammed what I did. I had a type def for string being char parentheses 80. So that all my strings were 80 characters long. But since I didn't include the type def here, maybe I'm just going to do, you know, const int or pounds define, you know, string size 80.
Constant defines, those are easy.
Yeah. All right. So here we go. I want a sequence number. I probably spelled out the whole word. I want a data value, and I want a word to play with. Char word subscript string underscore size. We need to end our structure definition with a semicolon, and then I'm going to type def. And one student who was texting me over the weekend had a case where they couldn't actually get their structure to work until they added a type def for it. And I haven't figured out, I haven't analyzed why they were getting that error, but I said, you know, just as a wild guess, type def it. And he did, and his problems went away. I'm convinced. Type def data point with a capital D just to differentiate it. Nope, 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 that's wrong. You list what your type, it's not like a pound define. Type def struct data point, and then you give it a name. Capital D data point. Alrighty. I'm going to create a new main. I'm not sure why. Main2. And I'm going to call main2 as the first line of code inside main. And then I'm going to return 0. Just so I don't see any of that other stuff anymore. Let's test out our structure. Let's malloc one. Data point, star. Well, we don't even have to malloc it. But we would have to fill it all in. I'm just going to call it D1, and then D1 dot, sequence equals, whatever. D1 dot X is equal to whatever, and then string copy D1 dot word, comma, banana. And just so we can print out our data easily, we may want to print it multiple times during our debugging processes. Why don't we write a little function called print data. So void print data, print underscore data. It's going to take a pointer to a data point, just so it's not passed in byte by byte. We just get a pointer, saves memory, saves cycles, passing things around. PD for a pointer to data. And I'm just going to issue some printfs. Printf data sequence equals %d, x equals %d, word equals %s, \n, end quote, comma. And then since it's a pointer, I don't use the dot like I was doing down here. I use a hyphen greater than. So PD hyphen greater than sequence, comma, PD hyphen greater than X, comma, PD hyphen greater than word. So now I'm going to print my data out. Print underscore data, and I'm going to pass D1 into it, but I better pass it in as a pointer, so I need to pass in its address. So I'm going to put an ampersand there. Then let's see if it works. GCC July30.c, warning implicit declaration.
You don't have string.
Yeah. So # include string.h. Just put that up there at the top. I'm going to do a compile showing warnings just to see how bad I've messed up so far. So -wall with a capital W, July30.c. It's clean at the moment. Alrighty, now to run it. /a. Alright, it worked. We created a structure and we put some data in it. Now, when we were playing with structures, if we wanted to initialize a structure with data, we did something like this. Data point D2 is equal to, and we initialized it. We have a couple ints, and we had maybe a string. But that's not going to compile.
Why is compiling. No, it's going on.
Okay, I'll be right there. Oh, and is it going to compile even though I just said it wasn't going to?
Wait, what does it require to compile?
I don't think I ever actually ran the compiler. GCC July 30.c. Yeah. So the problem is that in this language you can't copy a string in, a constant string in, and have it fill in an array like that. You can do stuff like that in Java, in C++, but it won't do that. You can't create, you can't initialize a structure in that fashion. So that's why I can't just do that when I want to make a new object. So let's write a function that will malloc. And we can pass in pieces of data like this, and it'll fill it all in.
Let's write a loop that will call it whatever.
So
Malloc all the states between.
maybe we ought to split the set and the malloc functions. So let's write one called void SetData, which takes three members, one for sequence, one for x, and one for word. Int sequence, int x, int word, but we also have to pass in our object itself. Okay. And I'd actually rather pass that in as the first thing. So I'm going to close my parenthesis, come back to the beginning, and do DataPoint star PD. And here we just fill in our pieces of data. That was supposed to be a comma, not an ems. DataPoint star PD, comma, int sequence, int x, int word. All right, so PD arrow x equals x, PD arrow sequence equals sequence. In object-oriented terms, what this kind of class is called is a mutator.
I don't like that word.
Yeah. And then the word, we have to string copy it in. So string copy, parentheses, PD dash, or arrow word, comma word. Now we can test that out. Down here, since that completely failed, I'm not going to mess with it. I'm going to delete that line. But I'm going to call set_data, passing in the address of D1, and I'm just going to give it some values. 100, 200, 300. And then I'm going to print it out again. Print_data, ampersand, D1.
Yep.
Oh, silly mistake. What did I do wrong? It's complaining about my word parameter.
The word.
Word is actually supposed to be a character array, so char star. And then ./a to run it. All right. So my little setter function is actually working. It set my values equal to 100, 200, 300. So let's create an object called, a function called malloc data, which will malloc a data point, set its sequence number. If we're going to set data like this, let's not pass in the sequence number, because if we're going to leave that alone. Sorry. Alrighty. So let's call this object, this function, something like create object. Void or create data. and it's going to take x, int x. It's going to take a word, char star word. The sequence is going to be created from a static variable. So each time we create a new chunk of data, we can have a new variable. So static int sequence equals 0, and then we'll use that in a minute. Give it plus plus when we're actually going to set our data. Now, if this is going to create an object, we better not make it of type void. It actually needs to return a pointer to the object it's supposed to malloc. So I'm going to replace that word point with DataPoint star. So I need a pointer, DataPoint P, or DataPoint star P, or star PD, pointer to data. PD equals, and I'm going to call malloc, but I need to cast its data type. I guess I'll do that at the end. Malloc, parentheses, the size of a data point. But like I said, we have to cast it. So before the word malloc, I'm going to do the cast to DataPoint star. So parentheses, DataPoint star end parentheses. So let's set the sequence of the data. So PD arrow sequence equals sequence plus plus. We're going to just increase that sequence number every time we run through this function. And let's also set X and word. Tell you what, we have our object created. Why don't we just call SetData? So set underscore data. We're going to pass in our pointer. We need to pass in the sequence value, sequence, but we want to increment it when it's done. Yeah, well, why get fancy? Let's just make it sequence, comma, and then X, and then word. And then on the next line, sequence plus plus. And then it's supposed to return our freshly minted object. Return PD. I'm just going to make sure this compiles. I haven't even added a call to it yet. GCC July 30.c. Error. Implicit declaration of malloc. For Pete's sake, somebody remind me what we have to standard lib, std lib, to get malloc, # include std lib.h. Yeah, much better. Okay. I had to, yeah, to get malloc to work, I had to add that # include, # include std lib.h.
Did you compile it yet?
Yeah. And then down here is my CreateData function. And down in main, I'm going to delete all this stuff, and I'm just going to create some objects using CreateData. So DataPoint star PD1 equals create underscore data. My data value is 100 and my word is orange. And I'm just going to copy and paste that and create a couple of other objects. DataPoint PD2. His data is 50. He's an apple. And data star PD3, 25. He's a banana. And let's print those guys out. Print data PD1. Print data, I should copy and paste to speed up things, PD2. Print data PD3. How small can I make that little window? Alrighty. GCC July30.c /a. Alright, so you see my sequence number is incrementing every time I call CreateData. In object-oriented terms, that's kind of serving as what's known as a constructor. Also, sometimes people call it a factory. It makes new versions of the structure, makes new objects, and then does some special stuff on the way to it, on the way to giving it back to you.
I've got a question.
Yeah.
So when you compile something with GCC, what is it like output as? For example, like when you do it on like in Sigwin, it doesn't have file extension, right? So that's fine in Linux. But like if you're like writing an app or something like that, and you see like what does it write the file?
Well, if you were compiling it with a native Windows command line compiler, sometimes you have to run the linker separately. The Microsoft tools make you call the linker specifically and it'll make a .executable file in the Windows binary format. What it's doing here is, since we're running Sigwin on Windows, it is creating a Windows binary format, but it's not requiring the use of the extension. So if I was creating this so that I wanted to run it just from a Windows, be able to double click it or whatever, then I would use the -o, and give it an exe as a file name.
Naming an exe.
Right, just naming it exe will do. Yep. All right, so we're getting really close to the point where we could create a file and write this data out, or we could create a file and read this data in. Now when we read it in, what I'm planning on doing is using Fgets to get our data, and then scanf. And yeah, there's also an fscanf, but as I've already mentioned, it's foolhardy to use scanf rather than it's foolhardy to call scanf on data that has not been validated as of being the correct length, because if you're reading too much data, it'll fill in your array past the end of data, buffer overrun. But we should test this out before we start messing with that. Why don't we ask the user to give us 3 pieces of data, and then, well, let's write a string function that'll chop up a line, a string, using scanf into its components, into X and the word and the sequence number. I don't even know if it needs to return anything. I guess it could return the data pointer. Not really sure that matters. DataPoint star parse underscore data. And we're going to take a data pointer as our object, so star PD, and we're going to take a string, char star SZ, 0 terminated string. So let's declare our 3 variables. S for sequence, X for X, and then what's the maximum size of our word? We created that with string size. Okay, so string size, char word, parentheses, string size. And if I'm going to call these other things by their entire value, I may as well use the entire word sequence. It doesn't take that long to type it. Okay, so let's use scanf to parse our string into these 3 variables, and then we'll set them in our object. Now when we're parsing our data, when we're pulling this data in, I don't think I want to call CreateData. And the reason why is that's always giving it a new sequence number. But what if I want to preserve the sequence number that we read from a file? So I think I'm going to malloc again rather than reusing this function. So I'm going to do that. Oh, I'm not. Yeah, I am. I'm not mallocing nothing because we got a pointer already. So PD, we haven't parsed yet. So string scanf, scanf, pass in our string, sz, pass in what we want to read. We want to read two numbers, %d, and then a word, %s. %d, %s, end quote, comma. And now we need to pass in our variables, pointers to these variables. So ampersand sequence, ampersand x, and then word, or ampersand word seems to work. And now let's fill in our object with those pieces of data. So set underscore data, parentheses, PD, comma. Let me make sure the order, yeah, PD sequence X word. So set data underscore, or set data, parentheses, PD, comma, sequence X word. And then we could return PD.
Did you like delete the SetData function?
No, SetData is still up here.
Okay.
Yeah. And you're pronouncing data correctly, and I'm calling it like a character from Star Trek. Data. All right. So just to test it out, let's make a string which contains some data. Data. All right. And then is equal to, okay, sequence number of 567. The X value of it's going to be 890, and then our word, secret word, is going to be great. So the name of our parse function is parse underscore data. So let's do that. PD1, no, wait. Parse underscore data, passing in our pointer, PD1, and then that data we just allocated. Just to test it out. And then let's print it again.
Can you scroll up?
Yeah, I can scroll up.
Why do you have a parentheses there?
I don't need a parentheses there. That was a complete mistake. Or do I? When you create a string, I need angle braces, right?
Yeah.
Like that. I could have just passed that in like this. But I'll leave it like that. I'm going to delete some of these PDs so that I can get more stuff on the screen. I deleted PD2 and PD3 just in the interest of getting everything back like that. And I'm going to compile it. String sep, undeclared identifier.
Oh, it's all caps, right?
The string size.
Isn't like all caps with an underscore? Could you do a define or?
Oh, I did a # define, yeah, and I should have put it in caps, and yeah, okay, so back down in here in parse data, this needs to be str underscore size right there. I made a mistake here. All right, and so it used our string to create a new data element, 567,890, great. So we could read this data from a file. So I'm going to use TextPad to create a file, which just contains, you know, some sequence numbers and X values and words. So file new. All right. Element number 1 has a number 100. It's got a bobcat. Element 2 is 50. It's got a lion. 3 is 150. Got a tiger. Who knows what these numbers mean? 150 and 150, whatever. These are prices. How much does it cost to buy a tiger on the open market? Alrighty.
50 Bitcoin?
Yeah. Alrighty. So we got a dolphin, and this will be about enough to prove the point, I think.
A dolphin more than a tiger? Analyze.
That's right. We're going to say that rabbits have a real low X value for some reason.
Because you gotta feed your lines and hide your block.
Yeah. Okay, so I need to save this file in the same directory as the .c file, or when you specify your file path, you better specify the whole path. So I'm just going to call it input.txt. So I did a save. I'm saving it in the same file as my C file. I'm going to go back to my C file. It'd be nice to write two versions of CreateData. One that just pure does a simple malloc. But on the other hand, we can always just call the simple malloc. Okay, so let's open our file. File *fp equals fopen parentheses input.txt. Now we ought to ask the user maybe, but anyways, end quote, quote, r, end quote, semicolon. If fp not or equal null, we have a problem. Printf, file not found. Be nicer to print out the file name. I should have stored input.txt in a variable so I could print out the file name. The user would not find it useful just to spit out file not found without telling them which file we were looking for. And then let's return just bail out or return error no, something like that. Yeah. This business about where we created a string called data and we parsed it and printed it, that's not really germane to our code anymore. I'm thinking about deleting it. Even this print data here. So these 4 lines I'm going to make go away. You can keep them in yours. All right, now let's issue while 1. We're just going to keep going until.
While forever.
Can you do 4 with like 2 colons too?
That would do the exact same thing, and that's actually, yep, that's more C-like. All righty, there we go. I am going to need a buffer to read into, so I should not have deleted my data buffer. Char sc or char data subscript string underscore size. So what are we going to do? We're going to get, I'm just adding some comments to Blue Sky. We're going to get the data. We're going to create a new object. We're going to parse the data. Now this is really sloppy programming because nothing ever goes and frees the objects afterward. And then we're going to print it out. So really maybe we would be putting these in an array or some other kind of structure. And maybe we could just reuse the same structure over and over and over so that we don't have a memory leak. So maybe we shouldn't create the new object. I'm going to delete that line. Okay, so fgets. I'm going to sneak a peek at how we did fgets down here. Alrighty, just like that. Fgets data 80 fp. Okay. So char star ret is equal to fgets. Let's pass in the file pointer, fp. Let's pass in our buffer name, data. Let's pass in the size of the buffer, str, comma, size. And in the PowerPoint, I have a fancy function that'll check to see whether we hit the end of the line inside that fgets. And if we didn't, it'll keep calling, get C until it does hit the end of the line. And it'll also terminate, it'll also re-terminate the data at the new line so that we don't have a new line character. But if we're just going to use scanf on it, that new line character is not going to mess us up. So supposedly at this point we have data, but we need to make sure that it's not null. So if ret is equal to null, we have a problem. Let's just break out of it. Otherwise, let's call ParseData, parentheses, pass our object in, which we called way up here PD1. I guess I'm just going to stick with that rather than create a new one, instigate a memory leak. PD1 and then the data that we read. And let's print our data out after that. Print underscore data PD1. I wonder if this is going to work. Didn't think so. Alrighty. Fgets. Again, I did it in the wrong order. Even though I scrolled down there to make sure that I did it right, I did it wrong. In some functions, the file parameter is the first one. In Fgets, it is not. It's the last one. So, not FP comma, but comma FP. And don't try to launch it as a Java app. Alrighty. Okay. Return with an error now. Okay, I guess I declared this as a void, so I better not return anything out of it. Where did I have my return statement? After I tried to open it. Okay. I guess we could make it int. Fastest way to solve it. Okay. I made main to an int rather than a void, just to get rid of an error message. Or I could have changed that line. Alrighty, it compiled it. /a. And there we go. It opened our file and it spit out the data that was stored in it. And really, I wish we'd gotten to this lecture like, 2 weeks earlier so that we'd been doing lots of file I/O. I feel comfortable not doing a big lecture about writing to a file because you already know how to write to screen using printf. So you could just write to the file using fprintf. If we had another lecture period, I'd like to do binary, writing a file, create a structure, and write that out as binary rather than a string. Why would we want to do that? Because if we were reading and writing as binary, we could just read in the structure with one call rather than reading a string in and then parsing it. I don't need that, but I need to pause this because I know that some people need my eyes. So just upload that and have a great break, whatever you're planning on doing for the next couple of weeks.
Getting ready for the next round of
Right. I feel like I should just get a computer science to and be a programmer.